Hi all, welcome to part 14 on combination circuits. See here we are continuing our discussion on encoder. Particularly we will see something called priority encoder. So in the previous video lecture what we seen is the basic encoder, right? So hope you remember. So where we taken this octal to binary encoder as an example, and we saw that the inputs to the encoder is like some 0 to 7, some 8 inputs are coming and 3 outputs are going. So each output x, y, z, they are represented like 4 OR functions are enough, like that we saw, right? So this is the basic encoder, and where we have a restriction like at any time one of the input is supposed to be 1 and all other inputs should be 0. Then only it can understand that here you mean for d0 or d1. If I am making d0 and d1 to be 1, it will be confused. So which is to be converted to the binary form, right? So which is to be encoded, so that it will be confused. Such a confusion is not there when this priority encoder is coming. So as far as this priority encoder is coming, you see here you can make more than one. So here we are taking a small example where some 4 to 2 conversion is happening, right? So 4 inputs are coming. To encode any of this information, some 2 bits are enough, right? So some 2-bit output will come. So that's all. Now, and there is one more output is there, v, that we will see. So that is a different thing. So maybe just for saying that whether the output is valid or not. So some valid bit is also there. That is different thing. So basically some 4 inputs are coming and 2 outputs you are getting. Valid input, whether your output is a valid output or not. So that is the meaning of valid output. So okay, fine. So that about it. So now see, in this case the first combination of the input is given like all zeros. That we don't want, right? So we can understand which information you want to encode. So that is where that valid bit is giving you a 0. So you can see that this valid bit is giving you a 0 when you are applying this input like this. So that is where, for what we are using valid bit. So I'm saying that you encode the information such that all the inputs are 0. So all the inputs are 0, it will be confused. So which is to be encoded, right? So that is why it is saying that the input is not valid. So 0 means the input is not valid. So this is the invalid case, right? So let me write it as invalid case. Now for valid case you want, so all these are valid cases. So what is the requirement for a valid case? So here valid means at least one input should be 1. Invalid means all inputs are 0. Fine. So if all inputs are 0, it is invalid. If at least one input is 1, it is valid. So here you can see that only d0 is 1. Now what does this mean? Right, this is actually representing 2 rows of the truth table, but this truth table is written in a condensed way. So this here this output x is don't care. Don't care meaning you know. So what is don't care? It can be 1 or 0, whatever it is. We are not caring this output, right? Because valid input is saying that it is an invalid output. So nobody is going to look at the output. Let it give an output as 0 or 1 for x and 0 or 1 for y. So this is your don't care condition, right? So here this x corresponds to this x and this x, they corresponds to don't cares. But what about this x? So these are all not don't care. So this is actually again same meaning, 0 or 1. So used to give a compact truth table. So that means on the background, if I am writing like x1 0 0, it actually means 0 1 0 0 and 1 1 0 0. I mean this part is varying, right? So this one row actually corresponds to 2 rows in the corresponding truth table. Now tell me, if that is the case, what about this one? Say what about this particular row? Okay. if I'm marking like that, you know what I mean is this particular row you can see that it's written like a XX10. Actually, what does it mean? This x and this x can be 0 or 1. Actually, 0 or 1 means you will be getting 4 combination. Like, so this can be 0 0 1 0, or it can be 0 1 1 0. This 1 0 is fixed. This you can vary, or it can be 1 0 1 0, or it can be 1 1 1 0. Right. So in the truth table, that's third, first, second, third, fourth. Right. That fourth row XX10 is actually corresponds to 4 rows of the truth table. Then tell me what about the last row, that is triple x1. Triple x1s. I mean the first d0 can be 0 or 1, d1 can be 0 or 1, d2 can be 0 or 1. So altogether you will get 8 such possibility, right? Because 3 binary variable is giving you two choice each. So 8 combination, and in all the combination this d3 is fixed to be 1. So that is the meaning. Actually this is a truth table of 16. So right, so the 16 row, and that 16 row truth table, I so not me in the textbook, they are giving a compact notation like this, so that will convey the meaning of priority encoder also. That could be the reason, but you have to visualize the same truth table as 16 row truth table, then only you can minimize the expression, because here we are not having some trick like what we seen before. Here you have to do the normal minimization only, so that you have to use a 16 cell K-map, and that time you have to correctly map the information into the K-map, something like this. So for doing this, you should visualize it as a 16 row truth table. Okay, so keep that in mind. Now here the requirement is, so if you are looking at this x100, it is actually 0100 and 1100. So here exactly one input is 1, here two inputs are 1, fine. Here also, here exactly one input is 1, here two are 1, here two are 1, here three inputs are 1, so that also fine. So what I need is at least one input to be 1. If all are 0, that is invalid for me. But what about the basic encoder we saw in the last video? There we want exactly one input to be 1. Exactly one input. Otherwise that will be confused, right? So here we are allowing more than one input bits to be 1. And if more than one input bits to be 1, which will be encoded? So that is a question. So there we are assigning a priority for the input pin. Accordingly we will encode information. Okay, so we have inputs like D0, D1, D2, D3, and the priority order is as per the number given. So assume that this D3 is having the highest priority. So that is the assumption. Okay, if you want, you can make D0 also highest priority, but in this explanation, they assumed that D0 is having highest priority. If you want D3. If you want D0 to be highest priority, accordingly also you can design the circuit, no issue. But in this example given in the textbook, they are assuming the priority like that. So first you understand the priority order. So D0, this is of lowest priority, and this is a priority order. So D0, if you are looking at the priority order, you can see that the least priority for D0, D1 is having more priority, D2 is having much more priority than these two, and D3 is having the highest priority, right? So that is the idea. Now if this D3 at any time I am giving D3 as 1, right? So I mean this combination, at any time I am making this D3 as 1. Let me take a different color. Yeah, at any time I am taking this D3 as 1, then actually what about this D0, D1, D2? They can be 1 or not, whatever it is. So at any time if we are saying that both D2 and D3 are 1, for example, so that the input will be 0 0 1 1. So other inputs are 0, for example, and D2 and D3 you are feeding as 1. So that is the input you are giving, say 0 0 1 1. And now what the circuit will see, it will see which are all 1s. So it can see that D2 is 1 and D3 is also 1. So which is having the highest priority? D3. So it will give you the so 4 inputs are there, right? So the encoding of these 4 inputs will be for D0 0 0. For D1 the encoding will be, so the encoding you know, right, because this is the encoding we are having. For D0 it is 0 0. For D1 it is the normal encoder encoding, not priority encoder encoding, 0 1, and for D2 it will be like 1 0, and for D3 it will be 1 1. Now my question is, for the encoder, let me draw this so that it will be more clear. So this is my encoder. And it is a special encoder called the priority encoder, because I am assigning some priority or I am assuming some priority for the input. So what are all my inputs in this example? So there are only 4 inputs, say D0, D1, D2 and D3. D3 is of highest priority also. And there are 2 outputs, X and Y. And there is one more special output called valid. So for a valid information, this V will be 1, fine. Now suppose I am feeding the input like 0, 0, 1, 1. It can be anything, you can give any input, fine. So what the circuit will do, it will see whether D0 is 0. So which are all the inputs 0? I mean 1. So as far as the user is concerned, user want the encoding of D2 as well as D3, because they are making that D2 and D3 as 1. Now the priority encoder will check the priority, and it knows that the higher number corresponds to the last D3 is having highest priority. So irrespective of D2, D0 and D1, if D3 is 1, it will always give you the output 1, 1. Right? That is the meaning. So that means I am giving the highest priority to D3. Whether you are making D0, D1 or D2 1 or all are 1, right, whatever it is, if D3 is 1, definitely the output will be 1, 1, the binary encoder form of D3. So that is a priority encoder, right? So as per priority, it will see which, when more than one inputs are 1, it will look at the one with the highest priority and it will convert that into binary, and also it will make this V to be 1. Means it's a valid output, right? So that about it. Now let me tell you another case. Suppose I am giving the input like 0, 1, 0, 1. I am giving something random. Okay. So now also you can see that this D0, D1 is 1, D3 is 1, and the highest priority for D3. So D3 will be given as the output. I mean you will get the output as 1. Okay. 1, 1. Sorry. Now the next question is, suppose this is the case. So now it will check, so see D0, D1, D2 all are 1. Anyway D3 is 0, fine. So we don't have to consider it. Out of the inputs which the user want to convert or encode, you can see that D2 is of highest priority and that is 1. So irrespective of the value for D0 and D1, it can be 1, 1, 0, 0, 0, 1, 1, 0, the 4 possibility. That is why we written like don't care, right? So if D2 is 1, definitely the output will be 1, 0, provided D3 is 0. So that you have to keep in mind. So D3 should be 0, then only this will happen. So it is 1, 0 means, yeah, I assumed that X is the higher, MSB bit. That is why 1, 0, the binary of 2, that's all. Similarly, D1 and D0. So when you will get D0, 0, 0 as the output, only one case, D0 should be 1 and all others should be 0. In that case only you will get 0, 0 as the output. Right? In all this case, this valid bit is also 1. So valid bit is going to give you a 0 when all the inputs are 0, because that is meaningless, right? Hope it is clear, right? So that is what we are written here. So when all the inputs are 0, valid bit is 0 and output can be anything. They are just don't guess. Then if D0 is 1, and all other higher priority inputs are 0. So that is why you are considering D0, because out of the inputs, the highest priority input which user want to convert is D0. So you are getting 0, 0 as the output, the binary of D0. Now here D1 is 1 and other higher priority inputs are 0. So you don't have to worry about D2 or D3. D1 is 1, right? Now whatever be the input given to D0, whether it is 0, 1 or 1, 1. So the highest priority goes to D1. So it will convert it into binary, that is 0, 1. Fine. So, binary of 1. Similarly here D2 is 1. All others are, D3 is 0. That you have to ensure. D3 is 0. So that is why the highest priority goes to D2. Whatever it is D0 and D1, you will get the binary of D2. That is 1, 0. See here, this is the last case where D3 is 1. So where definitely priority will go to D3. So it will always give you the output as 1, 1 irrespective of D0, D1 and D2. Right, hope the truth table is clear. Now, once it is clear, how you can implement it? That is the question. So, this is the theory part. You can go through it. Priority encoder is an encoder circuit that includes the priority information also. So, in addition to other information, here we have the priority information also. The operation of the priority encoder is such that if two or more inputs are equal to 1, at the same time the input having the highest priority will be given the precedence. So we have this precedence order. Highest priority input will get the precedence over the low priority inputs. In addition to the two input x and y, we have two outputs. We have a third output called v, and this is a valid bit, right, indicator of whether the output is valid or not. So if it is all inputs are 0, and that is the case where you are getting v equal to 0, everything I am explaining here. And what is the meaning of this x 1 0 0? It can be 0 1 0 0 or 1 1 0 0, like that. Okay, and where in the output they corresponds to don't care, so that also written. Okay, everything is written clearly. So according to the table, what is the meaning? If D3 is has the highest priority, so regardless of the values of the other inputs, whenever D3 is 1, the output will be 1 1. Similarly for D2, right? So that basic working also you know, and this is a true table. Now how to implement this? So you see here, if you are looking at this true table, you may be confused. So I request all of you to write down the equivalent. So this is something easy for you to understand the meaning. So to minimize the expression or to implement the circuit, you have to know the 16 row input. Let me write it like D0, D1, D2. So I'm just denoting here D0, D1, D2, D3, and the outputs are like X, Y, and V. And you know, if all of them are 0, 0, 0, it's like we are not worrying about the output. It can be anything, but the valid bit is 0, saying that it's an invalid input. Now what is the next case? In normal case, it is 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Like that, you know how to write it, right? So I will show you few entries and you fill the table accordingly. Now, what is this? Here D3 is 1. So if D3 is 1, irrespective of other bits, the output will always be 1, 1. And it is a valid output, so this will be 1. Similarly, here this D2 is 1 and other bits are whatever it is. Just ensure that D3 is 0. So that's all. So the output will be 1, 0 and valid bit also 1. Now here D2 is 1, but see D3 is also 1. So the highest priority will go to D3. So the output will be 1, 1 and valid bit also 1. Here also D3 is 1. So 1, 1, 1. So like that you can write. Hope it is clear. So you can fill the truth table and see which are all the entries where this so first you have to find out what is your D3, and to find out D3, so this is our normal minterm order, right? So this is your minterm 0, minterm 1, minterm 2, minterm 3, minterm 4, like that you will get some 15, 0 to 15 minterms, right? So if you are looking at this variable x to minimize it, you can see that minterm 0 is x, fine, minterm 0 is x. So that is how you are getting this entry. And minterm 1, 2, 3, 4, they are all 1, 1, right, 2, 3, 4 is also 1. I think here there is some small mistake. You just do it yourself. I'm doubtful, right? So here this 4 has to be 1, right? Some problem with this truth table. So you just minimize and see whether you are getting this or not. And similarly, I think this x can be here we are trying to minimize this x. It is don't care in only one case, that is in M0 only. Here also it should be 1, like that I feel. So you just come up with the actual truth table and the K-map representation and reduce it, okay? D0, D1, D2, D3, fine. So M4 corresponds to 0, 1, 0, 0, 0, 1. Sorry, I made mistake, yeah. This was like, I'm extremely sorry. This is my mistake. So what kind of mistake I made? So this is your, so what is the next combination? It was like this, right? So if this is the case, you will get the output as 0, 1. See, I written wrongly because in order 0, 1, 2, 3, 4. This is 4. Next only we will get to 5, right? So 5 is like 0, 1, 0, 1, M5. So here this is, here D1 is 1. So I need the output as 0, 1. So here I need the output as 1 1. So I written this entry first. So that is why it created that issue. Okay, fine, M4 is 0 only, fine. But this again you cross check, but because 0 0 0 is the only case where this x is found to be 1, right? So I think this is 1. Okay, that you verify. Okay, and finally you can the grouping and all. Here you can simply make a two bigger group, some eight cell grouping, right? So this is one grouping and this is another grouping, and accordingly, so this will cancel out the d0 to d0 and d1, and here 0 to 1, d2 cancel, and d3 only remains. Similarly, from this grouping you will get d2. Okay, fine. Anyway, hope that simplification everything is clear now, right? Similarly, for y you simplify and see the circuit. And what about v? Valid bit is actually the requirement is like I want either d0 or d1 or d2 or d3 to be 1 to make this valid bit 1. So valid bit is as simple. So this kind of a logic we applied for encoder, hope you remember. So in that way we are directly writing valid bit, not using the k-map. You can use k-map, but that will the minterms will be like here and there. Okay, you will get this. So but we don't need it, right? So if you are using the k-map, how the k-map will be like, see, valid bit is 0 in only one case, so the k-map will be something very complex. All entries are 1 except that m0, and many grouping you will get, and you have to simplify and minimize, but you don't have to do that much. So just like what we done in the last video, here you know that valid bit is giving you a 1 in the case that either d0 or d1 or d2 or d3 to be 1. So that you can simply express using a 4-bit OR gate, right? So that is enough. So that is how you are getting the expression for v. And you can do it using k-map also, but k-map simplification, it will be tedious for you. So that is why I am asking you to do it by having this observation. So yeah. Now once you get the expression for x, y, and v, you can implement, right? So this x is found to be OR of d2 and d3, right? Similarly, y is actually d3 plus d1 d2 complement. So that is what is implemented. Similarly, your v, the OR of d0 d1. What is your v? Yeah, sorry. Here you are already getting when you are taking this output, you are already getting d2 or d3. So that is why they are taking like this. Fine. Right. That about it. Yeah, thanks for watching. Doubts we will clear in the live class if you have any.